My name is Michael Holloway. I want to welcome you to the Lubrication Reliability webinar in the time of COVID-19. Today, we're going to hear from Rich Wurzbach, he's president of MRG Labs. We're going to go over the new look for lubricant analysis. It's going to take approximately 58 minutes. We're going to have questions and answers if we have time. Please stick around, though, because we always do offer up a quick questionnaire at the very end. That really helps us tighten up these webinars and hopefully get some information back to you that'll help out going forward. You can stick around. We also have another webinar coming up in approximately 2 hours. So you can log out, grab something to eat, and come back in, or just stay on, whatever you feel like doing. It's completely fine. Anyway, sure do love the fact that you're here with us. I'd like to introduce Rich Wurzbach. Go ahead, Rich.
Great. Thank you, Mike. I get the chance to kick off the second week here of presentations from a group I'm really proud to be a part of, including Mike Holloway, who you just saw, Mike Johnson, and Matt Spurlock. And I get to kick this one off today. Here's just a little bit about my background. I've got 30 years experience in lubricant analysis and machinery reliability. I've worked at places like the Peach Bottom Atomic Power Station, the National Institutes of Health, and various manufacturers around the country and even overseas. I'm a current machinery lubrication engineer and CLS, have other certifications as well, the founder and president of MRG Labs, and the co-chair of the ASTM DO2 Committee on In-Service Lubricant Integrated Testers. The sessions, the areas that I want to discuss today is talking about taking a new look at lubricant analysis and the roles that oil analysis laboratories play in that. I'm going to talk about some of the trends that were there prior to the outbreak. I'll talk about the COVID-19 impact on the sample sent to a central lab model. I'll give some future projections on changing economies and how that might impact sampling. How that might impact our oil analysis labs, what near-term effect we might see on asset performance, talk about how oil analysis laboratories can grow and help their customers at the same time, and then kind of finish up with what I see as the future of lubricant asset management. This focus on assets comes out of the last presentation and some of the questions that were asked, including a question I got from Ken Brown from Canada. And so I'm going to treat it in that way. Well, some of the challenges in today's COVID-19 environment, I kind of borrowed this from my earlier presentation because that's how I kicked things off when I talked about grease analysis last time. We've got these stay-at-home orders that are reducing available personnel to take the samples in the field. So we operate a lab here in York, Pennsylvania, and we have seen that impact where there's just not as many people available in the facilities. The asset owners are having to make difficult decisions about where their labor is being directed right now. And in many cases, that means that the labor that used to be there to take oil samples either isn't there or has been redirected to do other tasks. Some industries, such as power generation and food production, obviously medical facilities, research facilities, they remain open. And in some cases, they're out there at peak production. So you have this situation where you don't have as many people to handle the asset management workload that you have in the past, yet you're asking your equipment in many cases to work like it never has before. We've got critical tasks that are being prioritized, and many of our routine tasks are being delayed, and that includes routine maintenance, that includes extending out our lubrication intervals in many cases, and of course, in some cases, eliminating the oil sampling tasks for the time being. When we get into extended lubrication intervals, that can lead to wear particle accumulation, contaminant ingression, lubricant oxidation over time, and possibly a loss of protection for these assets. So we may see critical assets having an increased failure likelihood due to lubrication neglect. That's just, may just be one of the casualties. Obviously, the human casualty is the greatest thing we're facing right now, but we may see issues related to the performance and ultimately failure of our critical assets. So some idled assets, which have been idled just because of the shutdown of certain segments of the economy, may have moisture intrusion when they're cold. We might see corrosion taking place while these components are awaiting restart. We may have components that in the past, while idled, would be cycled or would be manually rotated or have lubricant added to them. And because of prioritization of tasks, that might not be happening right now. So all this kind of comes together and creates a really challenging situation going forward. So what is this sample to central lab model? If I turn back the clock on my work history, I was hired right out of school to build an oil analysis laboratory inside of a power plant. And I was, given boxes of equipment, quite advanced lab equipment too, including analytical ferrography and other instruments. And I built that laboratory solely for the purpose of analyzing the samples that we would take from that one facility. And so you saw that at that time back in the 1980s and maybe early 1990s that large asset owners would have their own laboratories to do analysis, or they might leverage laboratories that they had for other purposes like water chemistry or maybe cement analysis and utilize some of that to do their own lubricant analysis. But we saw over time then a transition to central labs to take advantage of efficiencies, to have companies focus, asset managers focus on their core competencies. And it might not have been thought that lubricant analysis would be one of those core competencies. And then also be able, with central labs, to take advantage of data agglomeration. In other words, when I was running a laboratory for one facility, my entire database and my history was all about a very finite number of components. When we have a central lab model, that central lab has the opportunity then to integrate that data from multiple sources, start to see data patterns, and use that in a positive manner to help understand what's going on. The sampling function remains with the asset facility when we see this transition, but there's not necessarily an internal validation of sample acceptability. When I first started, I was responsible for myself taking all the oil samples in the plant and then doing the analysis. And so you can imagine that I took the sampling function very seriously because I didn't want to have to tell myself to go back out and take another sample because you didn't do a good job the first time through. But there's also this kind of internal validation that takes place where when you've got a close connection between the analysis and the people taking the samples, where we can give that feedback and say, let's look closely at our sampling function. Let's make sure we're getting good samples so we don't waste our time. That tends to get disconnected when we're in a central lab environment. Yes, sometimes the central labs come back and say, we're questioning this sample, take a new one. But rarely does that go to the level of providing guidance and information about how to take a good sample. So sampling functionality can suffer in this environment. Sampling itself becomes an assigned task, often without having on-site expertise to ensure the sampling methodology. It may just be a checklist somewhere that says, oh, it's time for us to send off the oil samples. Let's make sure we got bottles full of something. And then we can check off that item on our list versus having the connection to the analysis process. So, to gain efficiencies in sampling, shipping and handling of these samples, we get tasks that are being grouped by intervals rather than optimized frequencies. So if we have, let's say, typically over a quarter, several hundred samples to send off for analysis, then we might see a tendency to group the intervals together and just say, well, here we are, we're going to be at the beginning of the quarter or at a certain time of the month or year, and we'll just take all our samples then. So there's just efficiencies in the sampling process, as well as the efforts to ship and handle these and send them out. Overall, what we end up with is an on-site tribology expertise, just the overall knowledge of that whole process from sampling and analysis, we see that suffering as the function gets outsourced in many cases. So what were some of the trends prior to the COVID-19 outbreak insofar as lubricant analysis laboratories and the lubricant analysis function may have looked? And we saw laboratory automation being quite common, but laboratory automation at the instrument level for the most part. We still would see manual activities for logging in, for sorting samples, for transferring samples from one instrument to the other. So still a very labor-intensive kind of process, even if some of the functions at the instrument level were being automated. We would see a focus for these laboratories on oil analysis and samples being submitted of basically any configuration, size, type of bottle, and sampling method being accepted. Now, some laboratories have worked more actively with customers and asset owners to try to standardize the sample size and maybe even the sample bottle, maybe providing sample bottles. But generally, most laboratories are not going to return a sample just because it's not in a certain type of bottle. They'll take what we get and handle it and go through with the analysis so we can collect the costs of doing that analysis. We see oil analysis contracts based on kind of a one-size-fits-all test slate, and with the focus being the lowest competitive costs. And as someone who operates a laboratory, I often get phone calls where the lead question is, how much does it cost to do oil analysis? And it's troubling when that's the first and the lead question. We haven't even talked yet about what that customer's goals are, what they're trying to achieve by performing oil analysis. They're jumping right ahead to the costs. And without that important step of evaluating the options that are there, the types of tests that can be performed, making sure that they match the goals for the assets that someone wants to monitor, often we get lost in the process just to find the lowest cost for oil analysis. We see contracts referencing ASTM standards, but often without any verification of that. We see very little in terms of analyst certification. There are interlaboratory studies that are performed by ASTM, but rarely are they included as a necessary component to ensure that the laboratory is performing tests in a way that's going to give a consistent, repeatable, and reproducible result. Often we find these programs are set up and the response from the laboratory is using something called ASTM modified. And all that means is we aren't following the ASTM standard anymore for whatever reason. And it could be to try to save on costs. It could be because the individual lab believes that some perhaps onerous or thought to be onerous requirement adds cost, but not a lot of value. But the problem becomes that unless we know exactly what those modifications are, we now have lost the standardization of the process and possibly have varying things going on with respect to what we've contracted these labs to do. We often have samples that are poorly identified by the asset owner, and these errors end up being propagated into reports and data trends. I remember when I was working with a power plant that was sending off some samples, and on a Friday, a sample went out. It got a result back very quickly that said that such and such a piece of equipment had a very high moisture level in the oil. Well, that started a whole series of actions that were required for that facility. And a few days later, the lab called back and said, we've looked at the label more clearly, and what we identified as the B pump was actually the D pump. So all of that action that was taken was done to the wrong piece of equipment. And we calculated that the cost of that evolution was the equivalent of several years of oil analysis program costs. So, being able to have good and positively identified samples is really critical. We've seen automated results evaluation become the norm. Recommendations, if there are any, with a kind of a minimal, if any, experienced analyst reviews. And when laboratories are kind of fighting each other to shave pennies off the cost of oil analysis, the expert analysis is often what suffers in the process. So if the primary driver being the price of oil analysis services rather than the net value provided, we get into this kind of commodity mindset. So what has the COVID-19 impact been on the central labs? Well, the sample frequency is reduced right now due to limited labor at the assets. And I know that ICML recently put a kind of a questionnaire out and got some responses. And Paul Hiller of ICML published those results. And most labs said that right now we're not seeing a lot of samples come in the door. We've seen in my laboratory a reduction in sample flow, and we even had a critical sample that took a very long time to get to our laboratory because the courier refused to deliver it because it came from an area that had a very high concentration of COVID infections. And so you've got these impacts that are having a negative or downward effect on sample frequency. So less samples are coming into the labs. The collecting of oil samples is often a lower priority than other tasks. So even if if some labor is available, it's likely off doing other things and kind of putting oil sampling on the back burner. The laboratories themselves, in many cases, are seeing reduced labor, and some laboratories have reached out to their customers and said expect a longer than normal turnaround time on your samples just because of limitations. And some of those limitations are just on fewer workers being available, unexpected reduction in the workforce, whether through illnesses or individuals that need to take care of family members that have illness or what have you. And in addition to that, we've got the challenges to maintain worker separation in a laboratory environment where workstations historically have been designed for efficiency of sample transfer. So we've put these instruments close together in little work areas so people don't have to go great distances to move the samples around through the lab. And as a result, it can become difficult to meet some of the separation requirements in the working environment under this COVID-19. We've got multiple handling of sample containers by multiple individuals throughout the laboratory analysis process, from the courier delivering the sample to the person checking and logging in the sample to the first subsampling, second subsampling, and so on. And historically, that wouldn't much have mattered, but now with COVID-19, we have to take a long, hard look at what do we need to do differently. And so the central lab model is dependent typically upon very small margins and very high sample throughput to remain profitable. And the future challenges that are presented by COVID-19 that I've just listed to this model are at this time unresolved. We don't know when this will end. There's talk about it perhaps subsiding, but then maybe coming back again. And if it's not this particular infectious disease, might there be others? And so we may see just general changes in how we perform work, how we exist as a society, how we interact with each others, and they may have a direct impact on how we've set up systems to analyze laboratories in the central lab model. Future projections for the economy post-COVID. So I kind of look to see what this is a very rapidly changing kind of thing, and folks are anxious and wanting to know what's going to happen next. Well, there was a Forbes article from April 10th that I reviewed, and it was entitled "Expect More Jobs and More Automation in the Post-COVID-19 Economy." And so you see automation used for a number of reasons, but one can be to minimize worker interface for not just COVID, but all communicable diseases. And so that, this article talked about that being kind of a push going forwards. You also hear about, wanting to have an interchangeability of individuals, less specialization, because if that specialized person is ill, not available for an extended period of time, how does that impact our process? And so we want to have a second person up, a third person up. We want to have cross training and not rely on breaks in our expertise chain by relying on one individual here, another individual there for specialized tasks, knowledge reviews. So there's three key factors that are outlined in this forward-looking article, which is automation, education, the prosperity of human workers. And this is achieved through a skilled workforce partnered with automation. They're not mutually exclusive. And a lot of times we think about robots and automation as job killers, but not necessarily. They can actually be job creators, job enhancers. Automation can make the job more safe, and we can see that now as we think about the interfaces and the handoffs in a typical laboratory. More greatly educated human workers then can provide a higher level of service through the data analysis and high value information. So the routine analysis, even the handling of the samples and the trade-off of the samples from one task to the next can be automated, and that allows our experienced workers, the folks in the laboratory who've seen a lot of samples, to focus on, how can we add a higher level of service? How can we look more closely at the data? How can we add high value information to folks who are coming to our experienced laboratory for answers about their lubricants? And so I do have a picture here of some automation that we have developed in our facility. And this is using a 6-axis robot that we call the Grease Monkey. And I'm going to bring up a YouTube video that just shows this in action. And so the samples in this case are grease samples. They're coming in a standard format with a barcode label. So any of the writing on there is really irrelevant to the robot. It's just looking for for the particular barcode to be scanned. There's that confirmation. The robot then takes the container, empties out the sample, returns the container because we're going to need that back when we're done, and now goes through a series of tests. We can start by weighing the sample, which gives us a sense of the total amount of sample that has been provided. We have a ferrous, an induction coil type sensor, which measures the ferrous content of the sample, and then a colorimeter, which compares the color, in this case of this grease, to the new fresh grease. When it's done, it's returning that to its original container in the shape that it was submitted and the orientation, so that a robot can pick that up later and do additional tests if required. And this was designed to create a automated process for screening samples, and this allows us to see results autonomously, completely autonomously, being run by this robot, with the data that's being produced being sent directly to the cloud. And by doing so, there's really no human interface at all, except setting up the rack of samples and turning on the robot and letting it do its job. So this, as we develop this automation for our laboratory, there was really some questions from folks, and says, well, how many samples are you doing in a day? Do you really need to automate that, or can that just be done by an individual basically creating the same tasks? And our take on this was, no, we want automation for other reasons. Number one is we want repeatability of the process. Secondly, we want to be able to create a low-cost screening process that allows us to look at a large number of samples without a lot of costs associated with it. So a asset owner can screen through those samples and only do the more advanced analysis on those samples that warrant it. And that's what we achieved here. The added benefit now of having a system like this in a COVID environment is that we can have one person in the laboratory, where we may have had 3 or 4 writing down data, transferring data, evaluating data, and so forth. This data is going straight into the cloud. One person fills up the rack, goes off to do other tasks, higher value tasks, that might include evaluation of data, or maybe a more advanced test like analytical ferrography, for instance, to look at what are the actual particles there. And instead of having the human being the repetitive task producer in the lab, we rely on the robot to do that. What are some of the post-COVID-19 impacts on sampling? So what are we going to see coming down the road from on the sampling side of things? Well, if we do see this reduced labor component, it might come about through the installation of a standardized and accurately located fittings. And I mean by that the oil sampling fittings. So I've got a picture there of a sample fitting and a mating plastic probe, a completely plastic probe that doesn't have to be flushed each time. There's not variability basically in, who's doing the flushing and how much they're flushing. It's just hooked up to the probe, the sample is taken, and the bottle is ready to go. An integration of a sample fitting, an interface probe, and even the bottle design to minimize that variation can allow these tasks to be grouped with other necessary activities. So you don't have to have a specially trained individual pulling your samples to know where they need to, what part of the machine they need to take it from or what have you. It's a simple standard operating procedure that says obtain the sample using these specific supplies from this located sample fitting in a recurring type of configuration. And I really started this in my first facility where, again, I was the guy responsible for taking the samples and doing the analysis until the program grew to the point where I couldn't do both. And I was told, you need to let other people take the sample. And I was concerned about that. Well, how much variation would there be? I always knew how I was taking the sample, but what kind of changes would be there? And so that's when I, worked on installing the sampling fittings and creating a standardized process so I would have continued confidence in the repeatability of those samples. There's also automated sampling options out there. A company called Logiloop makes a smart oil sampling station, which integrates to a sensor. And at the right time, when there are changing conditions on the sensor, this device can take a sample that will be representative of those optimal conditions, whether it's a optimal operating condition or maybe only take a sample when peak conditions or peak analysis is seen by perhaps by wear levels or by changing lubricant condition. Another thing is the use of sensors to reduce the sample load, not only in an automated sampling configuration like this, but in what I'd like to call condition-based oil sampling. Now, we're familiar with hearing condition-based, usually in the context of maintenance, condition-based maintenance, or maybe even condition-based oil changes. I'm taking it one step further here to say condition-based oil sampling, because really somewhere, and it depends on the industry and the age of the program, the maturity of the program, and how well the asset and the lubricant are maintained. But somewhere between 70 and 90% of most oil samples are determined by the laboratory to be satisfactory. And the comments will come back and say, all parameters good, sample at next specified frequency, which certainly guarantees another revenue stream. But basically, what was the value of that analysis to be told there's nothing to see here? We have resources that are being wasted in sampling labor, in the preparation of those samples and the shipping of those samples, and from the labor being done with the analysis with really no significant finding except, yes, we have a level trend. It really is a level trend from intermittent oil analysis. And that is really low value relative to what a sensor can tell us, because it doesn't reflect time-sensitive changes. If we have a completely steady state type of operation and the loading and other variables that affect lubricant condition and the rate of wear creation never change, then periodic oil sampling does a pretty good job at telling the story. But for components where that varies, like in wind turbines, where the wind is blowing one day, the next it's not, then it's blowing harder, it's coming from a different angle, it's putting different forces on the bearings and the gearboxes. that is the wear levels are very much going to change over time, and so that's where the sensors really help us understand that. The sensors see those time-sensitive variations in oil condition, the wear, perhaps contaminant levels, and they would trigger a sample only when it's needed for more detailed analysis. The sensors reduce the overall labor requirement for an asset owner oil analysis program because we're only going to take the sample when the sensor tells us it's time to find out more. It's not a normal sample that's going to give us the same data point as a month ago or last quarter. And as we see sensors being adopted, the demand for central lab oil analysis is invariably going to decrease. It's been a long time coming. Sensors have been out there for many years, but now we're seeing more and more use of them. We know that we have approach in terms of Industry 4.0. We've got the Industrial Internet of Things, and sensors are becoming lower cost, more capable, lower particle size detecting, and so on. And so as this becomes a tool available to decide, you know what, I'm not going to take that oil sample because the sensor says nothing has changed since the last time I sent it off, that's going to have a downward demand on central oil labs and the work that they're doing. So what is the impact and really what are the options? Because I painted a pretty grim picture for oil analysis labs like the one that I work in. We're going to see reduced samples and higher costs. And that's going to challenge this current model for high throughput oil analysis laboratories, especially now during this COVID period. And I'm sure a lot of labs are looking at this right now and saying, when is this going to end, and what is the impact going to be to our operations? The rise of sensors can put further strain on laboratories. And unlike the COVID-19 limitations, even after we get back to something resembling normal, or at least have a greater movement of labor and contribution, the sensors are going to be a permanent reduction in sample flow to the laboratories. So really, the options for oil analysis laboratories are differentiation and diversification. It's going to be necessary to differentiate your product offerings and diversify to compete and thrive. It's no longer going to be enough to outbid the other oil analysis labs by a few pennies per sample, because all of these pressures in rising costs, lowering oil sample flow numbers are all going to be working against that model. So it makes sense then for these laboratories to expand beyond oil analysis into fluids analysis and include things like fuels and greases and coolants in what they offer. Think about what is being offered by an oil analysis laboratory. It's a shift here from, how many samples can we get done in a day and how inexpensively can we get the results that are necessary, to what is the value that can be added. Add the value to the service so that higher margins are justified by a greater level of service. And a lot of times the asset owners are lacking the applied knowledge. You'll get the call and say, hey, I got this oil analysis report. Don't know what it's telling me. What do we have here? And there needs to be a follow-up conversation. That's if the asset owner has the time to make that call and to make that follow-up. But I think that oil analysis laboratories that recognize this and start to take that knowledge that is currently there and bring that to the forefront, that's certainly going to help for a differentiation. We want to see a reduction in cost further by automating the process, not just the individual instruments. So I showed a robotic process with a sample handoff. So we can really take the individuals out of that process, that we don't have to have folks stationed and standing at instruments and handing their samples from one individual to another, just from a safety perspective. And then to the laboratories, accept the coming sensor usage in Industry 4.0. Don't fight against it. It's coming. So be a part of it. Adapt data streams and analysis that can include and integrate the sensor outputs with fluid sample analysis results. As an end user, it's frustrating to say, hey, I've got these sensors here. They're telling me one thing. The laboratory's telling me something different. I don't know how to resolve them. There's incredible experience, years of experience in the laboratories that can be utilized to take them together and create an overall positive experience for the customer where the data sources are integrated and the knowledge that can be derived from it is clearly put forth from these multiple data inputs. Also, we can adopt grease analysis. And the reason for that is really in this whole model about the sensors is that, yes, oil analysis sensors are coming, they're getting better and so forth, but they're based on the principle that flowing oil washes over, if you will, a properly installed sensor and continuously updates the sensor output by new oil circulating through, pushing the old out of the way, and updating the response of the sensor. The problem with grease is that it is designed to stay in place. It's designed to hold on to and stick to surfaces, and that includes sensor surfaces. So it becomes very difficult to design a sensor that can work in an environment, in a fluid, which is not updating. You get a sensor output and it remains the same as the grease that's right there, on the rollers, on the gear teeth, and so on, is changing, might be oxidizing, might be having more or less contaminants, or the wear is increasing, and yet the grease that's stuck to the sensor head remains the same. So being able to use grease analysis is something that insulates against the coming sensor revolution, if you will, and allows the laboratories to continue to use what they have. And what do the labs have? They have instruments, they have skilled operators, and they have good customer relationships, and they have experience in turning those samples into actionable data for those customers. Most of the laboratory equipment can be utilized for grease analysis once we are able to handle the sample. But the first piece about grease analysis goes back to, once again, to sampling. And fortunately, there is a standard and a proven solution for grease analysis, and that's the grease thief. It allows installation in certain types of equipment in place of drain plugs, where it can maintain a purge function as new grease is added, and allow the excess grease to drain out of the sampler, with the most recent grease leaving the machine to be what comprises the sample. It can be used in a tool to be inserted into a machine to take a more active sample, either in a preset depth kind of coring sampling that I talked about a few weeks ago, or with a stinger probe that allows us to kind of fly blind, if you will, and insert until we mate up to a opposing surface, and then again core that sample so that we get that representative sample from the live zone. And once we have established that sampling program, and the asset owner is able to take that sample, then it can be analyzed. And one of the limitations on greasing is the typical small sample size that is available. The grease thief that I just showed and the methods outlined in ASTM D7718 produce about a 1 gram sample. It's not a lot of grease, and it's certainly not something that can be easily transitioned into existing oil analysis techniques and instruments. Grease is sticky. It sticks to itself. It sticks to containers and surfaces. And fortunately, we do have a method, a series of tests that can be used for grease specifically and in the sampling container that's provided. So the first thing is dropping that grease sample right into an induction coil for analysis, doing a dye extrusion, looking at the color that's there, looking at the antioxidants. And again, a lot of the instruments that you see here are the kind of instruments that oil analysis laboratories already have, and they're waiting just to be transitioned into grease. And as the sensors come along and have that downward pressure on demand for oil analysis, the grease analysis can step up and fill that void with the same skilled technicians, some of the same instruments, and use the knowledge that's there to help customers on the grease end of things. So with COVID-19, the question becomes, what is the near-term impact on asset performance? So with the current shutdowns that we have in certain industries, other industries will continue to operate, but the assets that are in extended shutdowns waiting for the COVID restrictions to ease, starting those assets is going to be problematic. It's going to result in increased failures due to lubricant condition, contamination, corrosion that's taking place, because it's unlikely that folks are taking the time to go around and jog equipment to replenish the lubricant, to make sure that the head spaces are being splashed with lubricant so that they don't get corrosion, to move bearings that might vibrate a little due to plant vibration and ambient, maybe from an adjacent machine, to move them around so that you don't get false Brinelling. A lot of that is going to be neglected. And once we start these assets back up, there's going to be a surge in failures. And some of that's going to be due to lubricant condition and contamination. The assets that are still out there being utilized, they're also, in a certain way, in many cases, being neglected due to low labor availability. You've got folks adapting to worker separation requirements. So, if you've got a component where normally, two people lift that component onto a cart and move it from point A to point B, now you can't put people working that close together. What do? You kind of sit back and say, let's make safety first, and let's figure out how we work on these components, whether it's kind of a maintenance activity, disassembly, preventive maintenance task, whatever. But a lot of those PM tasks are being put on the back burner now by using the low labor that we still have to do the most critical tasks. So I expect that we will see a spike in failures as the world reopens. And so what can laboratories do about that? Well, laboratories can contribute by offering restart lubricant analysis services. What do I mean by that? Well, as we take a plant that's been maybe shut down for a few months, before we crank this stuff back, what about a sample kit that gets set out to the facilities that says, take some shutdown samples and let's see if, and first off, how do we take the sample? Where does it come from? And how will it help us understand what's going to happen when this lubricant starts to get recirculated back into that machine? Maybe it involves having to jog equipment to start it briefly, what have you. But those samples are really going to be critical in helping us understand, is there a risk? And should we do something before we start up? Should we be purging greases? Should we be doing an oil change, and so on? And then also, for these components that fail, understanding why they failed. Is the backup also in the same condition, and might it fail? We can't answer those questions until we understand what the root cause of that failure is. So laboratories can offer failed component root cause analysis, starting by send us the lubricant, send us the grease, send us the oil, but also combine that information with maybe surface wear patterns and other things that help folks understand it. And this is something that my laboratory has done for a long time, because we recognize that it's something that goes hand in hand with lubricant analysis, is looking at the component and understand what are the causes of failure, and then what do I do going forward, both from a kind of a proactive maintenance perspective, as well as what should I be monitoring and what should my test slate be looking at from a lubricant analysis standpoint, so that I can see these root causes starting early and intervene before I get significant damage. Another thing is we talked about with the shutdown is the accumulation of contaminants. And a couple weeks ago, I talked about particle counting in greases, how that's now part of the D7918 standard. And we can confirm the cleanliness of new greases. Now, this could be greases that have been sitting in a grease gun for months, the greases that could be stored in a processing or in our storage facilities, maybe in transfer containers, and oils as well. But I think we understand particle counting in oils real well. Just want to mention this from grease so that we can monitor these areas as part of this return to service. And I have been sharing some information about new greases. And I think we want to look at this and think about this in the context of standby grease, right? What has happened while the machine was shut down? What happened while our greases have been sitting for months, maybe in not the best protected conditions? Have they gotten dirtier? have they gotten wetter during this time? Has there been condensation? So we can test those for particulate cleanliness, for moisture cleanliness, and really try to have an impact, positive impact on the failure rate of the newly started up components. So how can a laboratory help establish an effective grease analysis program in partnership with the asset owner? Well, the first step is to either obtain or partner with the lab having the grease sampling and analysis capability. So either supplement the oil analysis instrumentation that you have with components, with instruments that have dual capabilities, or that perhaps help you prepare that grease sample to use in your oil analysis instrumentation to have dual capabilities. And if that isn't something that you have going or would take time, then reach out and partner with a lab having those kind of capabilities. And from the grease thief analyzer that I talked about here and the grease thief sampling kits, there are laboratories around the world, including in Asia and Europe, across the North America countries, as well, that are out there that could be partners to help with that. The second step would be to provide expertise to help customers evaluate grease flow in the machine to determine the live zone target, because the sampling is key to customer satisfaction. I think this applies to grease and oil. I think laboratories can no longer sit back and say whatever lubricant sample happens to come through the door, we'll collect your money and we will give you results. That is just not going to be a good use of resources for those customers, and that satisfaction is not going to be good if the results don't correlate to what happens in the field. It really becomes important for laboratories to reach into that sampling process, to provide guidance, to provide the right kind of equipment, to provide training and oversight, and to give direct feedback when sampling is suspected to be inadequate. So that folks can, be able to use and lean on their laboratory for help in that regard. You want to be able to provide guidance and standard operating procedures for grease sampling methodology and conditions, because most customers are not going to have the experience needed, and that's going to be one of the first questions they have. How do I take a good sample? Create some cost-effective test slates, and that would include some low-cost screening to leverage the ASTM grease thief sample geometry. And I showed that Grease Monkey robot that does that autonomously and is able to do that at a low cost and very safely, in a very safe working laboratory environment, or even be deployed at the facility. We talked about sensors, and sensors are installed right on the machine, but an autonomous sampling and an analysis tool like the Grease Monkey could be used to get that immediate feedback right at the plant, so that labor that's spent to prepare samples and to ship them and so forth is only spent on that small percentage that are troubled samples that have increased wear, degraded grease, and so on. And then finally, review analysis results for systemic issues and help companies implement proactive measures to improve reliability and life for customers. A result, an oil analysis, a coolant analysis, grease analysis result isn't necessarily just information about that particular asset that it was sampled from. It could be insight into processes. It could help us understand that there's a cleanliness issue in how we're storing our greases, and that's going to then affect every asset in the facility that is impacted by it. So instead of maybe just saying, hey, there's a high particle count in this particular sample, the recommendations can be, let's go back, let's take a sample of the grease supply and the oil supply as a follow-up sample and see if it's your supply that's the particulate problem or the moisture problem, or whether it's getting in while it's in the machine because of shielding issues. This is where great value is going to be there for the customers, and the laboratory can start to play a wider role in helping them get to that point. So what's the world look like post-COVID? How are we going to be managing fluids? The fluid analysis model in this environment must include value contributing activities for remote workers. What do I mean by that? Well, not everybody is going to come to the same location and work side by side or be able to walk down the equipment. We need to think about delivering data in a format that is of value to those folks that may be spending some portion of their workday remotely at home, separated, either because of another outbreak like this COVID-19, or just in changing policies that companies might have to have more people work remotely, just to minimize just infectious diseases in general as a way of business to mitigate risk going forward. That means we're going to have universal access to fluid analysis databases for the lab, but also for the asset owners. No longer can we have asset owners that are just waiting for someone to manually put together a report and email it, and then that email gets forward. Universal access, where folks can log in and see their data in real time, is really going to be critical, and is certainly a first step in helping to integrate the real-time sensor data and the discrete sample periodic sampling analysis results. Want to see a focus on demonstrating value by reducing unnecessary fluid changeouts, fluid replenishments, then that could be regreasing tasks, extending lubricant life and equipment life. All of these are there. The information is there in lubricant analysis, and it's up to both the laboratory and the asset owner to communicate in a way that helps take advantage of that. It's not just, hey, there's a problem over here, or I'm just going to defer my oil change. We can go much further than that to fully optimize lubricant life, extend lubricant life by looking at things like cleanliness and antioxidant health and so forth. And by doing so, by having continuously clean and properly specified lubricants, we're going to extend equipment life and that return on those assets. We want to see an embrace of improving the capabilities of sensors and integrate that into an overall fluid management offering. And that embrace of the coming sensor capabilities needs to happen at both ends. The asset owners need to look for those opportunities and create those cost benefit scenarios that justify investing in them. And the laboratories have to be a partner in that and not see it as a threat, but rather an opportunity to integrate sensors and discrete samples and periodic samples in an overall condition health information stream. And we want to be treating lubricants and other fluids as assets and focus on the return on net assets to demonstrate the value of a data-driven fluid asset management approach. Lubricants are treated as commodities. It's really sad, and we see folks, kind of again in the same way that oil analysis is treated as a commodity. Fluids, lubricants are treated in the same way, instead of realizing that it is an investment, that the lubricant itself is an asset. If we take care of it, if we invest wisely when we purchase it and we protect it, we can get a very good return on net assets by extending the life of that lubricant and the impact that it has on the asset that it's functioning within. We also want to step into the fluid sampling world as laboratories and create partnerships between laboratories and asset owners to ensure the entire process is optimized for meaningful results. I've been working with a sample bottle configuration that comes out of Italy from Mech Oil, which is a vacuum bottle with an integrated valve. So the bottle comes with a vacuum. The valve is in a closed position. We can attach it to the sample tubing that I showed earlier, attach that to an integrated sampling valve on the machine, and just by turning the valve, take a sample that is never contacting other surfaces, that is not allowing environmental contaminants to get into the sample. And when that comes back to the laboratory, that configuration, that sample bottle with a valve, can be fed right into an automated analysis system that goes from machine to machine, and the oil is pumped from the bottle into that processing instrument to minimize the amount of touches that happens in the lab. It's possible, and it's being done, and it should be done more. So the time to change is now, not to wait and see how long this lasts or what we need to do next or how quickly we can get back to normal. We may never get back to what we perceived as normal. we may be in a completely different world, and it's time for both laboratories and asset managers to work together to create new partnerships and to optimize those assets that are their equipment and the lubricants that are in that equipment. Thank you for your time today.
Rich, that was awesome.
Here we have, I'm not sure if Holloway saw this. Sorry, Michael, for jumping on you. But there's an excellent question in the Q&A. Is there an ISO code for particle count on greases similar to oils?
Hey, Matt, thanks for picking that up. It is a really good question. So we're probably familiar with the ISO 4406 code, which dictates the use of these ISO codes based off of the number of samples seen in a volume of oil in different size ranges. And they are 4, 6, and 14 microns. In other words, greater than 4, greater than 6, and greater than 14 microns. The technology being used, and it's part of the ASTM standard D7918, has the ability to see particles in grease down to 10 microns. So within that, we've created a different reporting, which is greater than 10, greater than 25, and greater than 80 micron particles. This has alignment with an existing particle size classification for greases known as the Hegman gauge method, being developed by ASTM and NLGI, and is consistent with some of the research that's been done by folks like Dr. Pete Lucht on what are the critical size particles that impact grease lubrication in a grease lubricating film. Matt or Mike, did you see any other questions? I think I got a minute or two left.
Nope, that was really the only one that came through.
Excellent. Thank you so much, Rich. I certainly appreciate it. And for those of you that are still on, you could stay on if you want. You could also use this link to get back on in about an hour after you finish your lunch or take a break or a nap or whatever you all have to do. And then we'll talk about setting up alarm limits. Matt and I will go through that, and also how it actually coincides with the COVID pandemic. So guaranteed to be an eye-opening experience for those out there. Anyway, feel free to stick around, or like I said, you can go back on. Look forward to seeing you again in about an hour. Thank you so much.